Hi, my name's Robert Jenkins. I'm the CEO and co-founder of CloudSigma, and I'm here at Cloudscape 7 today in Brussels. CloudSigma was founded in 2009, and we created the company because we wanted to create the same experience that customers were used to from their private clouds, but in a public cloud setting. So we're a public infrastructure as a service provider, but at its core what we do is provide a level of flexibility and control over the cloud and the environment that people deploy within our infrastructure that's akin to having dedicated or private infrastructure. As a result of that approach, we have a lot of very large customers, service providers, people like this, that want a very dependable, customizable infrastructure bedrock that they're then building out a service to customers and users with. So that's kind of our approach. And what we were talking about today was our vision and activities around bringing big data and big public data sets into the public cloud. And essentially the idea is that the data is getting bigger and bigger, and so we need to bring the applications to the data rather than the data to the applications, which was the old way of doing things. So the public cloud can be that environment where we essentially curate and host multiple large-scale public data sets in a public cloud, and then we're able to expose those single sort of copies of the data to multiple users. So you no longer need to have your own copy of the data, but you can compute against petabytes of storage without actually having to pay for any of that storage. So the public cloud's a really unique environment for doing that. And as part of that, we're also a member of the Helix Nebula Consortium. Helix Nebula has a marketplace, a cross-cloud marketplace that allows customers to come in, do their computing across multiple clouds, and then we're aiming to marry that with the data backend so that we can federate these data sets across multiple cloud providers. So you as an end user can come in, you can say, I want to do this computing or create this service on top of these data sets, and you can sort of filter that out and then get to a short list of providers and then say, okay, fine, I'm going to deploy with CloudSigma, or I'm going to deploy with T-Systems, or whoever it is, based on the cost and service offering of that particular provider. So with that work, we're also working very closely with the European Space Agency. We already have data sets hosted in our cloud that are available to end users, and we're building out with key marquee customers in the commercial sector use cases. So one of the examples I gave in the presentation this morning was actually the Rome, the kind of local authority of Rome, and they were working with the university there, and they took ESA data and they married it to a catalog of digital buildings, so that they were able to map land movement and overlay that with actual buildings. And what they found was they were able to then profile risk, and if they saw a building or an area had moved more than a certain amount, knowing the age of that building and the type of building, they could then infer a risk in terms of structural damage. And so by doing that, they were able to filter across an extremely large area instantly, and then immediately highlight to the local authority, these buildings could be at risk. And actually, as a result of that, they did find buildings that had actual structural damage, and they were able to identify it to an exact join and say the corner of this building on this street will likely have structural damage or is at risk. Go and check it. And so you can imagine how that kind of seems like a small thing, but how the massive impact that it would have compared to a local authority building inspector roaming around the city trying to find faults, when in fact he can waste his time on 99% of the buildings because they know that the ground hasn't moved, they know that there's no problem. So in this case, it's a massive optimization for the local council. And using similar data, you can do things like proactive pipeline monitoring. I'm an oil company. I have a pipeline that goes out to, the sort of into the North Arctic or whatever. I don't want there to be leaks. If there's permafrost melt or if there's just shifting in the ground and you've got thousands of kilometers, how do I monitor that? Well, again, the data's there in these data sets, and you can extract that data, you can create risk profile and say, well, if this land moves more than X, I want to be proactively alerted. I'm going to send the engineers out and they can adjust the pipeline so that we avoid having additional stress. So that actually has a positive environmental impact because it avoids leakages from pipelines, which are very damaging, and also, of course, it has a commercially positive impact for the oil company. They save money, and at the same time, they can avoid leaks. So there are really a lot of different services like this that can be built on top of that data. And so what we're doing is kind of democratizing access to this data. And what we really want is engagement from developers and from the commercial sector who come in and build services for end users that sit on top of that data. So me as a consumer can go in and go to a mobile app and put in my building and say, oh, please tell me if the risk profile of this building. Maybe I'm buying a house. Wouldn't it be nice to know that? Things like this. So these services can be built with the data that's available today in these clouds. And so that's really what we're engaged in 2015. It's really like the exploitation of this data and getting it out there and building an ecosystem around that.